How does pipe roughness affect fluid flow? Imagine water rushing through a pipe, hitting tiny bumps and uneven spots on the inside surface. These surface features are what we call pipe roughness. They are microscopic irregularities that can change how fluid moves inside the pipe. When fluid flows through a pipe, it faces resistance from the pipe walls. If the pipe surface is smooth, the fluid slides easily. But if the surface is rough, it creates more friction. This extra friction makes it harder for the fluid to keep moving at the same speed. As a result, more energy is needed to push the fluid through. This energy loss shows up as a pressure drop along the pipe. The rougher the pipe surface, the greater the friction. This means higher pressure losses for the same flow rate. In turbulent flow, where the fluid moves chaotically and velocity fluctuates, pipe roughness becomes a big deal. It influences the friction factor, which is a number that measures how much resistance the flow faces. Engineers look at the ratio of the roughness height, called epsilon, to the pipe's internal diameter, called d. This ratio is called the relative roughness. When the relative roughness is high, the friction factor increases. That means more pressure is lost as the fluid moves along. In laminar flow, where the fluid moves smoothly in layers, roughness has less impact. But as the flow speeds up and transitions into turbulence, roughness effects become more noticeable. Higher roughness causes more energy to be used just to overcome friction. This can lead to higher costs because pumps or compressors need to work harder. It can also limit how much fluid can flow through the pipe or requiring larger pipes to compensate. Practically, choosing the right pipe surface finish can save energy and improve system performance. Smoother pipes reduce friction and pressure drops, especially in high-velocity systems. But in small pipes or microchannels, surface texture matters even more because it can significantly influence flow behavior. In mechanical engineering, understanding pipe roughness helps in designing efficient piping systems. If the roughness is not considered, the system might use more energy than necessary or face unexpected pressure drops. By selecting materials with appropriate finishes and calculating roughness effects, engineers make sure the system runs smoothly and reliably. To sum up, pipe roughness increases frictional resistance, which leads to higher pressure drops. Its effect becomes more significant in turbulent flow and when the relative roughness is high. This makes roughness a key factor in analyzing and designing fluid transport systems.